Hello everyone, it's the Math Fizz Wiz here, and I'm here today with a new episode on probability. So I know that the subject of probability is a subject in which many students have problems. So I thought I can make a series of videos specifically on this subject. And today is going to be our first episode in this series. In this first episode, I'm only going to cover the most basic concepts and principles that exist in the world of probability. And you can follow and subscribe so that you'll be the first to receive any updates regarding my new episodes in the series regarding the subject of probability. So, the most basic thing in the world of probability is that it assigns to each event a number. This number is something in the range of 0 to 1. So it can be 0, and it can also be 1, and it can also be any number that you can realize in the region between 0 and 1. But what do these numbers mean? So if a probability assigned to an event is close to 0, it means that that event is unlikely to happen. If the number of the probability is somewhere near 0.5, it means that that event is nearly random. It may happen and it may not happen, and we're not entirely sure if it will happen or if it will not. And if our probability is close to 1, it means that that probability, that event, is very likely or very probable to happen. In order to give you some examples regarding the concept of events and their probabilities, here are some simple examples. So for example, assume that someone is talking about a zombie attack, for example, and they say that the probability of a zombie attack occurring is this number, which is 0.00001. As I said, as this number is very close to 0, it falls in the unlikely region. So when someone tells you that the probability of a zombie attack is this much, you can infer that a zombie attack is highly unlikely. For another example, suppose that the weatherman says that the probability of us having a rainy day is 0.55, and as this number is close to 0.5, it falls in the random region. So we conclude that the probability of having a rainy day is nearly random, and we cannot be entirely sure whether we will have a rainy day or we won't have a rainy day. And then, as another example, suppose that the weatherman comes again and tells us that the probability of the sky being blue is 0.999, which is very close to number 1. And therefore, we can conclude that this event, the event of sky being blue, is highly likely, as we all know. So these were a few examples just to make you familiar with the concept of probability. One other important point I would like to mention here is that sometimes in people's speech you may hear that these probabilities are reported in percentage. So for example, suppose that the weatherman says instead of 0.55, he comes and says that the probability of having a rainy day is 55%. But notice that these two values are exactly the same because 55% means 55 over 100, which equals 0.55. Or, again, someone can tell you that the probability of the sky being blue is 99.9%. And again, these two are the same because 99% equals 999 divided by 1,000, which again equals 0.999. So note that the probability may sometimes be reported using a percentage instead of simply giving us the number. So if someone is using percentage instead of these numbers, the probability 0 will remain the same, so it's 0%, but the probability 1, which is when an event is certain to happen, is 100%. So the probability in that case will fall somewhere in the region between 0 and 100%. Now we move on to one of the most important and basic concepts in the world of probability, and that is sample space. So as you see here, this is the definition of the sample space. So it says that a sample space is a space that contains all possible outcomes of an event. And it depends on what event we're talking about. I have some examples here for you, don't worry. So for example, suppose that we're talking about the weather. The weather is the event we're talking about. So it can have different outcomes. For example, the weather can be rainy, the weather can be sunny, the weather can be stormy, snowy, windy, or we may have a thunderstorm, for example. So this purple circle you're observing here will form the sample space of the weather. As I said, the sample space depends on the context we're talking about. So it's not a fixed thing. It may vary depending on what we're talking about. Another example is when we're talking about a zombie attack. So for a zombie attack, the sample space is very simple because it only has two possible outcomes. It either happens or it does not happen. There's no other possible way for a zombie attack to happen. It either happens or it does not. So this will form our sample space in this case. I will write another sample space for you just as an example to see if you've learned the concept of the sample space or not. Suppose that we're talking about the outcomes, the sample space of throwing a single dice. What will our sample space in this case be? Just think about it for a second. See if you have any ideas. If you know the answer, it means that you've learned the concept of sample space. But I'll give you a few more seconds to think about it, and then I will give you the answer. So, as I said, the sample space is the possible outcomes that an event can have, and it must contain all of them. So we must take care so that we include all of the possible outcomes. Now, think about what happens when we throw a dice. In other words, what can happen? What are the possible outcomes of throwing a dice? So it's very simple. When you throw a dice, a number will appear, and the possible numbers are 1, 2, 3, 4, 5, and 6. Therefore, this yellow circle here will be the sample space of throwing a dice, because it can only be one of these 6 options here. Now that you've mastered the concept of sample space, we move on to one of the most important points in the world of probability. So, the sum of the probability of all events in a sample space has to equal 1. This is very important, something that you should always, always, always have in your mind. So I will highlight it here for you so that you know how important this simple fact is. So for example, if the probability of a zombie attack occurring is 0.1 and no is the only other option instead of yes for a zombie attack, then we must have the probability of no being equal to 0.9 because of this fact, because this is something that is known. So this is something we can use to find some of the missing probabilities we face sometimes. And just as another important thing, we show the probability of an event using the notation P. So for example, in this case, we can write P of yes equals 0.1. And this means that the probability of a zombie attack occurring is 0.1. Or in this case, in case of weather, for example, this is just an example, we can have the probability of having a rainy day being equal to 0.4, just to show you how this notation works here. Now that we've learned this very simple trick that I've highlighted here, we move on to solve two simple examples. So the first example here says that suppose we throw a coin, and suppose that when we throw a coin, the probability of observing heads is 0.3. And the question is asking us what the probability of tails is. Some of you might solve this problem in an instant. But for those of you who cannot, I'll just give you a few more seconds to think about it, and then I'll solve it myself. Okay, so to solve this problem, we must first form the sample space of the problem. So what is the sample space when we throw a coin? This is a sample space. We can either observe heads or tails, and these are the only two possible options after throwing a coin. So this forms our entire sample space. And because of this fact here, this highlighted important fact, we know that the probability of observing heads plus the probability of observing tails equals 1. And notice that we already have one of these two. We know that the probability of heads is 0.3. And this will simply provide us with the probability of tails, which will be equal to 1 minus 0.3, which is equal to 0.7. And just as simple as that, we've solved this question in probability. Now, the second example is regarding a non-biased dice. So, first of all, what is a non-biased dice? Non-biased means that the probability of observing all possible values, so 1, or observing a 2, or a 3, or a 4, or a 5, or a 6, is equal. This means non-biased, just as you have in a normal dice. And my question is, what is the probability of observing any one of these numbers? So what's the probability of observing a 1, or a 2, or a 6? We know that these are all equal because the dice is non-biased, but what are they equal to? This is our question here. So again, like what we did with the previous example, we first form our sample space. So again, this is our sample space. And what are the possible outcomes? The possible outcomes are 1 to 6, just as I've described earlier. And we know that the probability of observing all of these is equal. So we can write probability of 1 plus probability of 2 plus probability of 3, 4, 5, and 6 equals 1. But we know that these are all equal. So instead of probability of 2 until probability of 6, we can write 5 times the probability of 1, because they're all equal to the probability of observing 1, and we have 5 of them. So totally we will have, when we also take into account this one, we have 6 times the probability of 1 equals 1. And therefore we will have the probability of observing 1 being equal to 1 over 6. And notice that the probability of observing 1 is also equal to the probability of observing all the other ones. And therefore, just as simple as this, we've been able to solve this question as well. So we've now reached the end of episode 1 of our probability series. Hope you have enjoyed it and hope you've learned from it. Please comment if you want any specific subject you want me to teach you and talk about, and also wait for the other episodes in the series of probabilities. See you next time. Bye.